This lecture is going to be on the moon phases, or the lunar phases itself. As you can see, we've got a new moon phase, waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, and waning crescent. These are the phases that are associated with the lunar phases in terms of how we see the moon being illuminated by sunlight. An important observation to realize is that I like to think of it as the right side of the moon is the active side of the moon. The right side, as you can see starting here, goes from being a new moon to a full moon back to new moon. So as it goes through its phases, it's important for you to realize the right side is being illuminated and being darkened. And that's simply because it's a relative position compared to that of the Earth and the Sun. We've got three bodies that are moving, so the visualizations we get, which is contrary to what people think, is that it's not from a shadow of the Earth. It's actually from its position in space. This animation shows the moon at 8 positions in its orbit, along with a picture of what the moon looks like at each position as seen from Earth. At any time, half the moon, or one hemisphere, is illuminated by the sun. As the moon orbits the Earth, we see varying amounts of the illuminated half of the moon, shown in yellow in this animation. The sun always lights one half of the moon. The moon's appearance changes throughout the month because of different portions of its sunlit half are visible from Earth. For each phase, examine how the view of the Earth is related to the view from space. We'll go through this a little slower here. Here we go. Here's a new moon. Notice the light is coming from the left side. Here's our first quarter moon. Here's a full moon, the far side over here, full. Over here to third quarter moon, and heading back to the new moon phase. And here's the animation again to visualize it. We go from new moon, first quarter moon, full moon, third quarter moon, back. Notice that the lunar phases are the result of us viewing the moon from a moving platform. As we can see here, here's our new moon phase. As it's moving, only part of the moon gets illuminated by sunlight. And as it keeps on moving, as it's orbiting the Earth, it keeps changing its position relative to us observing it from the Earth, which also happens to be moving. So notice, here we have the new moon phase where we do not see, where we actually see the shaded or the shadowed side of the moon. Here's a full moon where it's getting fully illuminated, and then it's heading back to its phases, back to new moon. Two key terms we're going to look at are called synodic month, which takes 29.5 days, and a sidereal month that takes 27.3 days. When we compare a synodic versus sidereal month, it's important to realize that the times are different for a very obvious reason. You may have personally observed that the moon goes through a complete moon phase cycle in about 1 month, and that's true, but it's not exactly 1 month. The synodic period of lunation is about 29.5 days. It's the time required for the moon to move to the same position or the same phase as seen by an observer on Earth. If you were to view the moon cycling the Earth from outside our solar system, the viewpoint from the stars, the time required is 27.3 days, or roughly 2 days. This is less than the synodic month. This is called the sidereal period, or the orbital period. Why is the synodic period different from the sidereal? Well, the short answer is because we're viewing the moon from a moving platform. During the moon cycle, the Earth has moved approximately 1 month along its year-long orbit around the sun, altering our angle of view in respect to the moon, and thus altering the phase. When looking at the diagrams and imagining it to scale, you may have wondered, why is the new moon, why doesn't it block the sun at a full moon, and why doesn't it block the sunlight from reaching the moon itself? Well, the reason is because the moon's orbit about the Earth is about 5 degrees off the Earth-Sun orbital plane. You may be asking, why are synodic and sidereal not the same? Well, the moon orbits the Earth every 27.3 days, but completes a phase cycle every 29.5 days because the position relative to the sun has changed. The moon's orbit, or needs to orbit that much further to return to the same phase. The moon's phasing cycle is 29.5 days. The word synodic means relating to conjunctions, and those conjunction events being the full and the new moon phases. This picture from the lab binder helps illustrate when and where the Earth, Moon, Sun systems are relative to one another. Notice in the new moon phase, typically occurs around noon, but we don't see it. Notice that the sun's rays, photons that are traveling in straight lines, are illuminating the far side of the moon, but we only see this side of the moon, so therefore we see its shadow, so therefore we don't see it at all. And as it moves through space, we only see this small fragment. Notice it's the right side, the active side of the moon, as it's orbiting the Earth. Here's the first quarter moon, we only see the half. As it continues moving to its waxing implies it's getting larger. Into the full moon phase, notice on the far side it's fully illuminated, and then it begins to wane. Notice it's the right side relative to an earthbound observer. What's important to recognize here is that there are some precise times that are associated with different phases. Notice sunset, or around 6 p.m., is where we find the first quarter moon being at its highest point, or zenith, and where at midnight is where the full moon is at its highest point, or zenith. And sunrise is typically around 6 a.m. Once again, these timelines of the Earth motions are simply the harmonic motions of the Earth, Moon, Sun system and how the moon is illuminated relative to an Earth observer. And last but never least, when we view the moon, if we could fast forward it, we would be able to see these phases taking place. And this would be, in our case, the way we would view or perceive the right side of the moon being the active side. Here it's being illuminated, and here it's being darkened. It's simply the shadow relative to our position